Hey everybody, good morning. Mr. Lake here with another chemistry lecture video. Today we are getting into covalent compounds. So for the last week or so, the last several videos, we've been really focused on ionic compounds, which are compounds formed when electrons are exchanged from one atom to another, thereby causing charges, or ions, and thereby causing electrical attraction to bond things together. We've been focused on that for a while. Now we're going to get into covalent compounds, which is a completely different way that atoms can bond to one another. It's still driven by valence electrons and the needs of valence electrons and the octet rule, but it works a little bit differently. So let's jump right in. This is going to be a new type of bond, and it is going to have a new system of naming and writing formulas. So be ready. All right. First of all, to review, ionic bonds form when electrons are exchanged. That's going to make one atom a positive ion because it's losing electrons. It's going to make another atom a negative ion because it's gaining electrons. And then the positive and the negative electrical charges attract one another, and those things end up stuck together in an ionic bond. That happens between something that can form a cation and something that can form an anion. That is a metal and a nonmetal generally. Could also be a metal and a polyatomic ion. There is also a positive polyatomic ion, so it could be a polyatomic ion and a nonmetal, but bottom line, it's something that forms a positive charge and something that forms a negative charge. Now, covalent bonds, which is the new type of bond we're talking about today, is formed when electrons are shared. So, for example, let's think about two atoms that both want to gain an electron. Well, so far, we've talked about, okay, if those two things want to gain an electron, they've got to find some other atom from the other side of the periodic table that wants to lose an electron, and that could give them an electron. But they don't have to do that. If two atoms that want to both gain an electron, or sometimes more than two, that all want to gain electrons, if they can find each other, what they can do is they could share electrons. So let's say that there's two atoms, they both have 7 valence electrons, they both want one more. Well, if they find each other and they can just kind of share a pair of electrons, each of them sort of half gives one of their electrons to the other, then suddenly both of them have access to 8 electrons and can achieve the octet rule. And that's the basis of covalent bonding. Generally, this occurs between two nonmetals. There's not very many elements that this is going to occur between because there's not very many nonmetals. It's mostly going to be carbon, nitrogen, oxygen, fluorine, silicon, phosphorus, sulfur, chlorine, bromine, iodine. Those are the ones that you generally see, in addition to hydrogen and sometimes helium. So there's not a lot of elements that are involved often in covalent compounds, but these are really, really common, and they're very, very common in life forms. Well, they're really common everywhere. So it's important that we learn about them. Now, it is still based on the octet rule. So remember, the octet rule tells you how many electrons something needs in order to fulfill the octet rule or fill its valence shell up to 8 electrons. But in this case, the number of electrons that something needs for its octet is the number of covalent bonds that it can form. So like chlorine, for example, has 7 valence electrons. It needs one more, and so it can form one covalent bond. Carbon has 4 valence electrons. It needs 4 more, and so it can form 4 covalent bonds. Now, I already gave you the answers to a couple of these because I wasn't thinking ahead, but think for a second. I'll pause myself, and you can pause the video. Think for a second, how many covalent bonds can these different atoms form? Well, carbon, like I said, has 4 valence electrons, so it needs 4 more, so it can form 4 covalent bonds. Nitrogen has 5 valence electrons. It needs 3 more, so it can form 3 covalent bonds. Oxygen has 6 valence electrons. It needs 2 more, so it can form 2 covalent bonds. And chlorine has 7 valence electrons. It wants 1 more, so it can form 1 covalent bond. Now, here's the interesting thing about covalent bonds. Oh, I guess I could have just shown you this slide, huh? Whatever. Here's the interesting thing about covalent bonds. Multiple covalent bonds can form between the same 2 atoms. So, for example, and I'm going to show you a visual of this in a minute, carbon can form 4 covalent bonds. So that means that it could form 4 bonds to 4 different atoms, or it could form multiple bonds with a couple of different atoms. So it could form 2 double bonds with 2 other atoms, or a single triple bond with 1 atom and 1 single bond with another atom. As long as the number of bonds adds up to 4, it can really do whatever it wants. So here's some examples of that. What you see up here at the top are 2 carbon atoms that are single bonded together, but because both of them can form 4 bonds, they each could bond to 3 other things, right? So if you just look at one of those carbons, it can form 4 individual bonds with 4 different atoms. But it would also be possible for 2 of those bonds to form between the carbons, in which case each of them would form 2 single bonds with other things. Or there could be 3 single bonds that form between those carbon atoms, and each of them would form 1 other single bond with something else. So this makes elements, especially elements like carbon that have lots of covalent bonding, possible. It makes it so that they're really versatile. They can form atoms of all different shapes and all different kind of strengths, and they can do lots of different things because they can form bonds with different numbers of things. They can form different kinds of bonds with different things. Because not only when 2 elements share multiple bonds together, not only does it change the nature of that bond and the shape of the atom, but it also changes the strength of the bond and the distance between the atoms. And by the way, this is a single bond, double bond, and a triple bond. Those are the names for those things. Whoops. But equally as important, when something shares a single bond, that's a certain amount of connection that they have together. When they are sharing 2 bonds, which means that they're sharing multiple electrons between the 2 atoms, that's a stronger bond. And if they share 3 bonds, that's really strong, right? It's 3 times as strong, although the math might not work out perfectly like that, but it's a stronger bond than a single or a double bond. You may be wondering if they could just form a quadruple bond, all 4 of their bonds together. Quadruple bonds are possible between some atoms, but it's not possible for carbon. And it gets into the physics of electrons and orbitals and that kind of thing. So can't really cover that here. But quadruple bonds aren't something we really talk about, at least not in this class, because they're very rare and they don't ever happen with carbon. So if you'd like to look more into that, feel free. You're more than welcome to do that. So let's get into compound nomenclature with covalent compounds. This is going to be really similar to ionic compounds in some ways. You're going to do a lot of the same things with the words, but you need to know your prefixes. Because in a covalent compound, you have to designate in the name how many atoms of each element are there. In ionic compounds, you don't have to because you can rely on the charges, but in this case, because things can form multiple bonds, you have to designate how many of everything are there. So let's do the covalent compound prefixes 1 through 10. Now, normally I would have people guess at these and we'd make a game of it, but I'm just going to show you. The prefix for 1 is mono. 2 is di. 3, tri. 4, tetra. 5, penta. 6, hexa. 7, hepta. 8, octa. 9 nona, and 10 deca. You might recognize some of these, like triangle or decade is 10 years, or octagon is a shape with 8 sides, but some of them might not be super familiar. Now, the way you're going to use these is that when you're naming a covalent compound, you do the exact same thing with the words as if you're doing a binary ionic compound, except you add prefixes before each of the words. So the first element is going to be named with a prefix indicating how many of that element are there, and then the full element name. And then the second element is named with a prefix showing how many are there, and then the element root plus the suffix "ide." So you do the same thing where you take the root of the word, but you change the ending to "ide." So like the first example here, C2H2, that's 2 carbons and 2 hydrogens. So it would be dicarbon, dihydride. So dicarbon means 2 carbons, and then dihydride is 2 hydrogens. It's not dihydrogen. You have to change the ending of the second word to "ide." And the other example, C3S5, that would be tricarbon pentasulfide, not pentasulfur, but pentasulfide. A couple of special rules that you need to be aware of. Mono is never used for the first element. So if there's only one of the first element in a compound, you're actually not going to use the prefix mono. You're just going to leave it without a prefix. Of course, chemists have to establish rules and then figure out how to systematically break those rules, right? And the other thing that you need to know is that sometimes, especially in the case of oxygen, you will drop the last letter of the prefix before oxygen. So if you want to say like 1 oxygen, it would be monoxide, not monooxide, because how that would read would be monooxide. So having 2 vowels right next to each other can be kind of awkward, and since oxygen starts with a vowel, we drop the last vowel of the prefix. So examples that show both of those things, CO is carbon monoxide, not monocarbon, just carbon, and not monooxide, just monoxide. The second example, SO4, is sulfur tetroxide, not monosulfur tetraoxide. You don't use mono before the first word, and you drop the vowel on the second prefix. That's just something that you will really get used to as you do more of this practice. So that's how you do covalent compounds. I'm trying to expand my thing so I can say goodbye to you. That's how you do covalent compounds. Thanks for watching. I will see you in the next video. Until then, take care of yourselves.